In the world of electric vehicles, there's a silent battle happening under the hood. A battle between two types of motors, AC and DC. But this isn't just a technical comparison. This is about understanding how these motors shape everything from performance to price, from charging to reliability. In this video, we're diving deep into both worlds, using real 3D visuals of a BLDC motor and an induction motor to see what truly makes them different. So let's begin. Electric vehicles are not powered by fuel, but by electrons. And these electrons have to flow through a motor. The way that motor is designed defines everything about the vehicle: its speed, torque, efficiency, and even maintenance. There are two main categories: DC motors, like the BLDC motor you often find in scooters and light EVs, and AC motors, like induction motors used in larger cars and commercial vehicles. We'll break down both, using accurate 3D models to visualize each system from the inside. Let's start with the DC motor, specifically the brushless DC motor or BLDC. These are one of the most popular choices for smaller electric vehicles. In a traditional brushed motor, brushes and a commutator physically switch the direction of current. But in BLDC motors, that's all handled electronically. There are no brushes. Instead, sensors detect the rotor position, and a controller switches current between the motor windings. This makes BLDC motors quieter, more durable, and more efficient, because there's less friction and no physical wear from brushes. The stator contains the windings. The rotor is typically a permanent magnet. The sensors like Hall effect sensors provide feedback to the controller. The controller switches the current precisely to rotate the magnetic field. These motors are extremely responsive. They can deliver high torque at low RPM and are perfect for stop-and-go traffic. That's why companies like Ather, Ola, and other Indian electric scooters rely on BLDC motors. They're compact, lightweight, and very efficient for city rides. But BLDC motors do have limits. They require complex controllers with advanced switching logic. The more precise the control, the better the performance, but also the more expensive the system. They're best for vehicles under 10 to 15 kilowatt range. But beyond that, they start getting difficult to manage efficiently. Now let's move to the AC side and explore induction motors, one of the most widely used electric motors on the planet. These are the same motors that power heavy industries, elevators, and now electric cars. The stator generates a rotating magnetic field using three-phase AC. The rotor is not a magnet. Instead, it's usually made of conductive bars shorted at both ends. Here's the genius part. As the magnetic field from the stator rotates, it induces current inside the rotor. That current generates its own magnetic field, which tries to catch up with the stator's field. And that's what makes the rotor turn. Induction motors are powerful. They scale beautifully to higher torque and higher speeds. That's why Tesla used them in early Model S versions. Tata's Ziptron architecture also relies on AC motors. These motors have no brushes, no permanent magnets, and are rugged. You can push them hard. They tolerate heat and vibration very well. But they are not perfect either. They require an inverter to convert DC battery output into AC. Also, efficiency drops at low speeds. That's why most modern EVs include gear reduction or hybrid motor systems. So now, let's directly compare both types. BLDC motors are more efficient at low to medium speeds. Induction motors are better for highway and high power usage. BLDC systems need complex controllers and magnets, slightly more costly. Induction motors avoid magnets but need high power inverters. BLDC motors offer better throttle response. Induction motors are smooth but slightly delayed due to rotor induction time. Both are low maintenance, no brushes. Induction motors are more rugged for long-term, high-heat operations. So which one is better? The answer is, it depends on what kind of vehicle you're building. For light EVs like scooters or compact delivery vehicles, BLDC is ideal. Or for performance vehicles or heavy-duty EVs, AC induction motors take the lead. Some EVs even combine both, using AC induction motors in rear wheels for power and BLDC in front for precision control. As battery tech and power electronics evolve, even permanent magnet synchronous motors PMS-EMC, a cousin of both, are entering mainstream. So the next time you ride an electric scooter or see a Tesla launch off the line, remember, the type of motor under the hood is carefully chosen to match the job. DC motors offer simplicity and responsiveness. AC motors offer durability and scalability. Both are powerful, both are smart, both are the future. If this deep dive helped you understand EV motors better, consider subscribing to Tech Explorer 31. We break down real engineering with visuals, not drama. Also comment below, which motor do you think will dominate in the next 5 years, AC or DC? Until next time, keep exploring.